everyone, my name is Cian, and together with Harry and Amber, we've been working on optimizing performance for recirculated packets in the OVS user space Datapath. So I'm just going to talk about that today in this lightning talk. So first I'm going to go over some general user space concepts in OVS, and then talk about the optimizations that we've done and their benefits, and then finally talk about validation of those optimizations. So the first concept we need to understand is DPIF. DPIF stands for Datapath Interface, and this is the glue code that connects the different major blocks of the OVS Datapath together, such as MIFEX or Miniflow Extract, lookup, and action. And the DPIF batches packets together and moves them from one stage to the next. Then we have Miniflow Extract, or MFEX. This is the first major stage in the OVS Datapath. And this is the block that parses packets. And so it understands which packets have what protocols in their headers. Finally, then we have recirculation. So in the normal case in OVS, we receive a packet or a batch of packets, and then they're passed through the DPIF onto the action stage, and then we find that we want to TX the packet somewhere. But for some use cases, additional passes through the DPIF are required, such as tunnel decap or contract. So in this case, for let's say tunnel decap, we receive a tunneled packet, it passes through the DPIF, and we're looking at the outer header or the outer protocols in the tunnel header. And then we find that we want to decap this tunnel header, and we do that, and then we recirculate the packet. We pass it through the DPIF a second time. And in this second pass, now we're looking at the inner headers of the packet. And so after we do that, we might find that the second time round, the action is to just TX the decapsulated packet somewhere. And so what we've done here is we've recirculated the packet. And this is necessary for a couple of different scenarios. This is another way of visualizing that recirculation. So in this diagram, I'm showing the two DPIFs side by side. The first pass, or for the non-recirculated packets, is in blue, and then the second pass is shown here in green. And I just want to highlight that there's some metadata passed from the outer DPIF to the inner DPIF. And this is important because this is what makes the inner DPIF and Miniflow Extract a bit different. And this is why today we have SIMD support for the outer DPIF and the outer Miniflow Extract, but not the inner or recirculated DPIF and Miniflow Extract. So this is the support that we want to add. So for DPIF, the changes are we want to skip metadata initialization on packets because that's already been done the first time through the DPIF. So the second time around, we don't want to get rid of that. We don't want to reinitialize metadata. And then we want to add some extra stats associated with recirculated or inner packets. And these are PMD level statistics. So this means, in order to do this in a maintainable way, we actually use a common AVX512 DPIF function. And so we add support for these extra changes that you can see at the top of this slide, and they end up being extra branches about, do we have an outer packet or an inner packet? Is it recirculated or not? And when we have a common AVX512 DPIF function, it avoids code duplication. But you might be thinking, well, it's unfortunate that we've added these extra branches, but we can rely on the compiler and something called function specialization to compile out these extra branches. So you can see in the diagram, we have two wrapper functions around this common AVX512 DPIF, and the outer and inner wrapper functions. And these pass constant values to the common function, and for example, it might say recirculation equals true or false. And then the common function is inlined into these two wrapper functions. And because that's constant and known at compile time, those branches can be compiled out basically. So we avoid those extra branches, which are in the C code. So then in the AVX512 inner Miniflow extract, we need to support extra metadata, which I've highlighted before. So this extra metadata is passed from the outer DPIF to the inner DPIF, and it's passed in the actual packet, so the DP packet buffer. And in Miniflow extract, we want to take that out of the packet buffer and put it in the Miniflow. And so this extra work needs to be done in SIMD or AVX512 code. And so what are the benefits of doing all this in AVX512? For the DPIF, it means faster packet batching. And the benefit is greatest in the worst case. So where we have small batch sizes, doing faster packet batching is more meaningful. So this is true for multi-flow scenarios, where you've got many different actions, and so your packets end up in small batches. For the Miniflow extract, this means faster packet parsing. And this is, again, this gives more benefit when you have larger miniflows, and you have larger miniflows on recirculated packets because of all that extra metadata. So if we can do all of this extra work in extracting more data with wider registers, we can do it in less instructions and we can do it faster. So finally, validation of all this. So both the inner Miniflow extract and DPIF are validated similar to how the outer AVX512 DPIF and Miniflow extract were validated. So that means for Miniflow extract, we use this auto validator approach, where the scalar and AVX512 implementations of Miniflow extract are compared. So we compare if the results of them are the same by running both of them at the same time and comparing the actual Miniflow. If the Miniflow is the same, we can be happy that they're doing the same thing. For the DPIF, this means having a compile time enable of the AVX512 inner DPIF and then running the OVS unit tests. And if we do this and all the unit tests pass, we can be happy that the DPIF is behaving the same way as the scalar DPIF, which we know is working. So finally, we're targeting upstreaming this code for 2.18. So we'll be submitting patches to the mailing list for review and merge. And reviews and comments, they're always appreciated and welcomed. So thanks a lot for listening to my talk. If you have any questions, feel free to reach out to us by email or through the mailing list. Thanks a lot.
I want to welcome our presenters Cian and Haaren to talk about their work. If we have any questions from anybody, please submit them via Q&A. So we don't have any yet. So if either of you want to say a few more words about your work, then please go right ahead.
Yeah, sure. Can you hear me, Ben?
Yes, I can. Just fine. Oh, and it looks like we do have a question. So this one is from Flavio Fernandez. Flavio says, is there ever a third pass of recirculation? I'm thinking of MPLS tags or stacked VLANs where there are multiple inner packets. Forgive me if this is not applicable. So what's the answer?
Yeah, well, we haven't tested with it, but I think there might be more than one pass. I know there's cases where you might have multiple layers of VLAN headers and tags. And well, yeah, it's a good question. And you know, if it's a use case that's interesting, it's something that we should definitely test and see if you know, if our implementation works for that, and then if we can improve it to work with that if it doesn't.
So my thought is that it probably happens. MPLS tags, even if there are several of them, probably aren't a case because because of the particular way that MPLS works. But my guess is that 3 passes of recirculation are actually possible. Harry, would you like to add anything?
No, nothing. That's fine.
I guess not, or maybe Harry is having trouble with audio. So let me thank all of our speakers one more time, and we should probably move on